All right, ladies and gentlemen, we are definitely in it for the long haul this time because here we have a very, very big question in paper 2, exercise 4. Now, this is the geometry and trigonometry question that's almost inevitable on every single exam set. It almost always appears. Um, Not this exact one, but many different ones. So anyway, let's get started and let's try and see if we can learn anything here. So the first thing that it tells us is using geometry software doesn't really matter. Pedro draws a quadrilateral ABCD. Big deal. So then it tells us the interesting stuff. AB is equal to 8 centimeters and CD is equal to 9 centimeters. This has been put into the drawing already so that we can easily see what it says. The angle BAD is equal to 51.5 degrees and the angle of ADB is equal to 52.5 degrees, which this information is also already put in for us. I'm going to get rid of these circles here because I kind of just find them annoying. But these are the main points of interest. And again, like it says, it's also shown in the diagram. So all you really need to do is look at the diagram already. So then it tells us, first A is to calculate the length of BD. Now, most of you guys figured this out pretty easily. You've got the side BD over here, and over here you've got these two. Now, hopefully it's quick to see that this side corresponds to this angle, and that this side BD corresponds to that angle. Once you see that correspondence, then you have to go, okay, we've got correspondence. That's cool. Is this a 90-degree triangle? And you look at it and you go, doesn't say. It doesn't say if it's a 90 degree, and if it does not say 90 degrees, you cannot ever treat it as 90 degrees. You have to presume that it is not 90 degrees. If they don't tell you it's 90 degrees, it's not 90 degrees, because otherwise they would tell you it's 90 degrees. Or they would show it like so. They would have this sort of thing indicating that it's 90 degrees. I say this because a lot of people, they try to use their 90-degree rules because they're simpler. You can't do that. You must use the more complicated rules. In this case, you would have to use the sine rule. Now, the reason we use the sine rule here is because we have two angles. The moment you have two angles, rather than say two sides, you know you're probably going to be using the sine rule. Now, the sine rule is as follows. I'm going to put sides on top, so that it would be like this. The side A can be divided with the sine of the angle that matches with A. And that can be said to be equal to B divided with sine of the angle B. This is the basic gist of the sine rule. The one thing to keep in mind is that if this side here is A, then this must be the angle A. Similarly, if this is going to be our side B, this must be our angle B. I'm going to use D, however, but that just means that I change this to a lowercase d. But the point is that you must always be able to draw these lines of correspondence. You must always be able to go, okay, this side D, it matches to this angle. If I go out from side D, and then I'll eventually end up at this angle. The same thing over here. If I go out from side A, I eventually end up down here at this angle, or vice versa. If I start at this angle and I go out, I eventually meet this side A. As long as that's true, those are the sides that you use. Now, let's look at this. Well, we already have the side 8. That corresponds to the angle of 52, 5, or dot 5, let's say. And we also know that we have the other one over here with A. We also, that's the side that we don't know. So there I'm going to put down BD because that's the side we're looking for, but it's also the same as A. You can see that this side B to D, that's the same as A. So, okay, it's just another way of writing it. I'm going to divide that with sine of 51.5 because that's the amount of degrees there are corresponding to that side. Now, the last step is, in principle, to isolate for BD. However, remember, GDC, you don't have to do that. You can literally use NSolve already if you want to. You can put this in as it is into NSolve, and nobody is going to give you any bad marks for it. It's completely fine to do that. The one thing that you have to remember to do, however, is you must remember to set your calculator to radian. Sorry, not to radians. You must remember to set it to degrees, because if it's in radians, you will have problems. If you do this, you will find that the answer is equal to 7.89. And I can even show you what I did if you want. But what I did was sort of the slower way, because I didn't use NSolve because I found it difficult, or rather I just found it pointless because I happen to know what to do here. So this is my solution, and this is my approach. Okay, but that's A out of the way. Let's move on to B. Now B says, show that the angle EDC is equal to 48 degrees, correct to 3 significant figures. EDC. Okay, so that's here, here, and then up to here. So we must be looking at this angle. How are we going to prove that that's 48 degrees? Well, we were just told that CE is equal to 7 centimeters. So up here, I'm going to draw another line, but I'm going to have to draw it with red because I'm running out of black space here. If I draw this line, this is supposedly equal to 7. Okay. So I've got a line 7. And then meanwhile, over here, I've got this one, which has dealt BD in half. But we already found out that the whole line, which I'll do in green, this whole line, that was 7.89. Correct to 3 significant figures. We also now have this line over here of 9. This green line, if we were to split it in half, I'll switch to orange for a moment to show it. Well, it would obviously be half of this. So the orange is just going to be 7.89 divided with 2. Then we'll have, let me write this out as clearly as I can, we will have 3 sides. I'm not going to figure out what this one is right now. I'm just going to say it's going to be equal to something. So we've got 3 sides, and we want to know an angle. What rule do we use when we have 3 sides and want to know an angle? We use the cosine rule. Not the sine rule, but the cosine rule. The cosine rule is always the fallback whenever you have 3 sides. Because only the cosine rule ever sees 3 sides in play all at once when you do calculations with it. So what does the cosine rule look like? Well, the cosine rule in its basic form will look like this, but you can rewrite it if you please. And you might have to for this problem. Let me just make that a little bit nicer. That's a little ugly. A 2. Then 2 times A times B times, and then cosine of whatever the angle C is equal to. Now, in our case, we're looking to use this to prove that this is 48 for us. That's what we want to know. We want to prove this. That means we cannot insert it. Can't insert. Let me just write that down. Cannot insert if proving something. So that's something to keep in mind, is you can't insert to prove it. You have to find it. So we're going to isolate for cosine C. Now, if we do this, there are a few different approaches. There is a rewritten formula in the formula booklet. I absolutely encourage you to use it because that would probably be the easiest. But again, we're on the GDC. We could just use NSolve, and that's exactly what I'm going to do. I'm going to use NSolve, and I'm going to write down that C here. Well, C must be the 7. So I'm going to make that red to show that's the side that I want to make 7. Then, of course, we've got A and we've got B. Well, this side here, this could be A, so let's make that the orange one. That, by process of elimination, means that B must be our blue one. So I'm going to insert those, and then I'm going to show that this last side, which, let's make it purple. Purple's a good color. Let's show that I can show this angle here. So I can isolate or show if I use NSolve and leave this one blank, so NSolve for C, I'll write that down and solve for C. Then I should be able to get the answer I want. So I'm going to put in all the numbers now. I'm going to say 7 squared equals 2. And I'm going to say 7.992 squared. Then I'm going to say plus. And then I'm going to say it's 9 squared. And then I'm going to say minus 2 times. Oh, okay. And so now I have my answer. Let me show you what I've done. I have used this, basically. Now, it doesn't totally fit here, but I'm just going to write then that I used a comma C here and then an end bracket. And what this does is it tells it I'm looking for solutions to C. When I do this, I get this number. This number, correct to 3 significant figures, is 48.0 degrees. I would urge you, though, include both. The reason you want to include both here is because this question is specifically asking for 3 significant figures. Prove you can do it by writing both, but leaving this one with the double underline under it to show that yes, it's correct, it's equal to 48.0, correct to 3 significant figures. That is the procedure for solving that question, is to use the cosine rule. Next, we have calculate the area of the triangle BDC. So here, here, and here. Okay, how are we going to calculate that area? Very simply. We already know the green side that I've shown, and I'm a little bit out of color, so I'm going to have to go with a bad one, like maybe this dark red. We know this side as well. We can probably find this angle quite easily. In fact, very easily. All we have to do is subtract these two from 180. Whatever's left over should be the angle here. So that's what we'll do. Then we can use the sine angle rule, which I will write down somewhere. I will write that down to the right. I'll write down that it's 1/2 AB times sine C. I hope you guys remember this formula, but it is in the formula booklet if you don't. This formula is the one we're going to use. We're going to treat 8 and we're going to treat our 7.89 as our sides, and then we're going to treat this angle here as C. So in order to do all of that, we're going to have to firstly find C. That's going to be equal to 180 minus 52.5 minus 51.5, because I think those were the sides, wasn't it? Yes, those were the angles. And we're going to do that on the GDC very quickly because I don't want to calculate it in my head, and neither should you, frankly. I get this to be 76. Now all I need to do is say 1/2 times with times the 8 multiplied by, and then I pick my length, which was 7.89, and then multiplied by sine of 76. And that will give me the area. This is the easy question, and ideally it should be possible for most people. But anyway, let me just do the actual calculation now to make sure that I get a good number. 7.89 multiplied by sine of 76. And I get 30 30.6. Let's just call it that. Because again, I'm rounding up to 3 significant figures. Ideally, that should be your solution. Okay. Let's move along and let's take the next one as well. This one is the hard one. So here, Pedro draws a circle with a center at point E, passing through point C. Okay, so basically, this right here, if it's a circle and has a center at E, it must follow that if it just passes through C, this must be the radius. So this right here, this would be what we call the R. Okay, it says part of the circle is shown in the diagram. Show that point A lies outside this circle. Justify your reasoning. So we need to try and see if we can figure out whether or not this one is smaller than R or bigger than R. So basically the question is it larger? Is it less than R, or is it larger? Which one of these cases are we in? So how are we going to show this? I'm going to choose an exceedingly simple way. I'm going to look at this and say, okay. Why don't we simply use the fact that we know how long this side is, calculate how long this side is, and then use this information to figure out how long this side is. That should be simple enough. But how do we figure out how long this side is? Very easy. Remember that we've already gotten, up here, we've already got this side over here, and we've also already got this side. We can use the cosine rule to calculate the final side, or you could use the sine rule, whatever you want. I don't really care. I'm going to use the cosine rule because I find that very simple. I'm going to go ahead and say that this side, I can just, in fact, I'll just indicate that we're using the exact same rule here. In fact, I could even copy it, and then change the coloring. So let's copy this. Let's make it a little smaller, and then let's change the coloring. So here, what we're going to use is we want to find the gray side, or the last side. So I'm going to make that gray. I'm going to use the fill tool. Then the sides that we've got are A, of course. And I'll make that one this color. And we've got the green side. Let's make that one green. So let's use that information, and of course also the gray angle. Let's use that information to figure out this side. So all I got to do is insert everything. And I'm going to do that very quickly for you, I hope anyway. Let me see. So it would be, yes, 7.89 squared plus 8 squared, and minus 2 times 7.89 times 8 times cosine of, and then I'm going to do the 76 that we used earlier. So that tells me that c squared is equal to 95.7. Or it could also tell me that c, I'll use the square root now, that gives me around about a side of 9.7 and then 8. Okay, so with that in mind, that kind of tells me, okay, so this side here, this is 9.78. Now remember, we've already got this side. This is our, maybe I should make it orange to match with what we've done before. I can use orange here and gray to get the last side, which perhaps I can make it a kind of gold color, this side. And then we can figure out how big it is. We're just going to use the cosine rule again, because once again, we've got this angle down here, and we've got, we've got our two sides that are next to it. This is a very good case to use a cosine rule. So let's do that. Let's simply use it again, this time with some different colors. So I'm going to copy this, and then I'm going to do the exact same thing again, but again, slightly changing around the colors. We're looking for the golden side now. We have the golden angle. The sides that we have are gray, and they are orange. Oops, sorry about that. Not everything can be sunshine and rainbows. There we go. So now that we do that, all we got to do is actually go into the calculator and do it again. We say this squared, the one that we used before, and then we simply say 7.89 divided by 2 squared, then minus 2 times, once again, same number, then times 7.89 divided by 2, then times cosine. And this time, the angle that we're going to be using is 52.5, so that's what we'll do. And with that, we end up getting, if you do this on the calculator, ideally you should get that, let me make it golden as a matter of fact, ideally you should be able to get that c squared is equal to 64.2847. Okay, that means that c, if we take the square root of this answer, is around about 8.02, give or take a little bit. But how long was this circle exactly from E to C? Well, the interesting thing is that CE, we already know that that's 7. It told us in an earlier question, remember? This piece of information here, that this CE is 7. So, now the question, is this golden line bigger than 7? Yes, it is. So that means that A, it's further from E to A than 7. So basically, if we want to go from E to A, it's this far, more than 7. Therefore, A is outside the circle, because the circle has a radius of and that's the argument. It's that the circle has a radius of 7, and to get from E to A is a distance of 8.02, which you can calculate via this slightly convoluted method, but then you get the result that you're looking for. I hope that that is somewhat explanatory.